try this example to design a braced slender column. These are the specifications of the columns. The concrete grade is 25, the steel grade is 500, exposure class XC1, fire resistance 1 hour, design life 50 years, the column size is 250 x 300 mm, the effective length is 4.13 meter and the slenderness ratio is 52. It is assumed that the reinforcement bar provided is 20 mm and the links provided is 6 mm. The column is subjected to an axial load of 1200 kN. There will be moment in the minor axis, where the moment on top of the column is 35 and the moment at the bottom of the column is 25. You may pause the video for a while for you to work out the solution. To solve these questions, first you need to refer to the formulas for the slender brace column, which is this. The MED will be the larger value of these 4 equations. Once you have determined the MED, substitute the MED into the formula here and also substitute the NED into the formula here, which give the y-axis and the x-axis of the design chart, and from the plot that you obtain from the design chart, acquire the AS. I use spreadsheet to help me to generate the result. The concrete grade 25, steel grade 500, exposure class XC1, fire resistance 1 hour, design life 50 years. The dimensions of the columns, effective length and slenderness ratio is given, as well as the loadings are given here. The moment now is bending at the minor axis. First, you will need to determine the cover of the concrete. This is done by referring to this formula, where you have C min and the deviations for the construction's tolerance. This theta C deviations is equals to 10 mm, while the C min is governed by the bar diameter 20 mm, the exposure class, which you have to refer to table 4.4n, and also a minimum of 10 mm. From table 4.4n, with a given exposure class of XC1, you are referring to the structural class S4. The C min durability will be 15. The C min here will be the larger value of the 3, where the bar size is the largest, which is 20 mm. With the C min to be 20 plus 10 mm, your nominal cover will be 30. Next, you need to refer to the formulas here for the braced slender column. There will be first order moment and second order moment. For the first order moment, you need to determine the M02 and also N0E. M02 is determined as the summations of the M top or M bottom plus the moment generated by NED times EI. With the given M top and M bottom, you know that the M top is a larger value. Therefore, the M here will be equals to 35 kN meter. NED is given in the questions, which is 1200 kN. Now you need to determine the EI. The EI is given by this formula, which is the effective length of the columns divided by 400 With that, you obtain the EI equals to 10.3 mm. The M2 will be the 35 plus the moment due to the NED times EI, which is equals to 47.4 kilonewton meter. M01 will be the smaller value, which is 25 plus the moment due to the NED times EI. With the M01 and M02 determined, you are able to determine the N0E as given in the formula here, which is 60% of M02 plus 40% of N01. These numbers needs to be greater than 40% of M02. Now that you have obtained all the moments for this first order, you will need to determine the second order moment. For the brace structures, the top columns will have 0.5 M2, same go to the bottom columns, and the mid-height of the columns will be about M2. The M2 is given by the formulas of NED times E2, where the E2 is given by these formulas. The calculations is rather lengthy. We shall look into them one by one as listed in the spreadsheet here. For you to compute the M2, you need E2. However, for you to compute the E2 here, you need this formula. C is given to be equals to 10 as a factor. Therefore, you have C equals to 10 here. Now you need to determine 1 per r, which is the functions of a curvature. It constitutes the Kr and K dot, as well as 1 per r naught. As demonstrated here, Kr, K dot, and also 1 per r naught. The formulas for the Kr is given here, where the respective formulas are given here. The Kr now is assumed to be equals to 1.0. Next, you calculate the K dot. It is given with this formula, 1 plus beta times coefficients of the creeps. The formulas for the betas is given here in terms of the functions of SCK and also the slenderness ratio. The slenderness ratio is given in the equations. Next is the coefficients of the creep. It is given by this formula. The ratio of this is assumed to be equals to 0.67. And for a typical class R concrete, at the age of 30 days with 80% humidity, this is the coefficients of frictions. Multiplying these two, you will get this. 1 plus beta times this, you will get this. Next, you need to determine the 1 per r naught. It is given in these equations. In the functions of the yield strength for the design, in the functions of the design yield strength of the steel bars, divided by 0.45D. This epsilon yd is actually can be quantified by these equations, dividing the design stress of the steel bar with the modulus of elasticity. The modulus of elasticity of the steels is given here. And the design strength of the steel bar, it will be the characteristic strength of the steel bar, which is 500 divided by factor of safety of 1.15. That gives you 0.87 FYK. Substitute the relevant value, you will get epsilon YD. Substitute epsilon YD into the equation here. With the D defined, you'll be able to obtain 1 per R naught. This is the value for the 1 per R naught. Now, for you to obtain the 1 per R for the curvature, you will have to multiply KR, which is equals to 1, with K dot, which is equals to 1.1977. And also multiply with 1 per R naught, which is equals to 2.37 power of negative 5. This is the value for 1 per R. Substitute the relevant value into the equations here, as well as the effective length of the columns. You will get E2. The E2 is to be multiplied with the axial loops. You will get the M2. With that, you are able to determine the moment for the second order moment. Next, you need to determine the M-mean. The M-mean is given by these equations, which is the multiplications of NED with E0. The E0 is determined by the H divided by 30, and the E0 needs to be greater than 20 mm. Substitute the value into the formula here, you get E0 equals to 20 mm. Now your M-mean is by multiplying this 20 mm with NED, you get 24 kilonewton meter. Refers to the diagram here. The MED will be the larger value of this, and also M-mean. These values are actually determined from the superpositions of the first and the second order moment. And your MED now is found to be 77.1 kilonewton meter. Next, you need to refer to the chart of the design columns.